Okay, so this is your week 6 notes part 1. There's going to be 2 different parts to this week. This is basically putting everything together. It's a little bit extra because I really haven't looked at the graphing or the table yet, but it's work that we've done before in class. And then the part 2 will be, you'll see a skill that I think that we just need to practice a little bit more based off of work that I have seen you guys doing in previous weeks. So it'll just be, that'll be a review. So this worksheet goes through taking a quadratic and solving it in different forms. And we actually are going to solve it in 4 different forms. If we're solving these, they should have the same answer every single time. So that's one thing to also watch for. You can kind of check your own work. And if you're not getting the same answer every single time you're doing it, that'll kind of let you know that you're doing something wrong. And then you can try it again. So we have the 4 different choices: Carlos, Clarita, Tayani, and Zach, or Tahini. But when we go to do this, I might suggest, if we're trying to pick an order, I would do, and each one's doing a different form. So Carlos is using a table. Clarita's going to do, I like to write the equation in factored form. Tahini is going to use quadratic formula, and then Zach's using the graph. I would start here. Okay, I'm going to start by using the quadratic formula. If you remember from what we did last week, the quadratic formula, no matter what, will tell you the right answer and the exact right answer. The other forms, you might be able to find close to it. You might be able to estimate, but the only one that's going to give you an accurate answer that I have taught you how to do is going to be the one that's the quadratic formula. Just like we've looked at before, in order to start the problem, we can't start it until it equals 0. So we're going to start by subtracting 6 from both sides. So x squared plus 5x minus 6 equals 0. And again, I'm going to move it down here so we can start with this one and then use the quadratic formula. So if you have to, remember, you can go back to last week. You can watch the video, you could sing the song, but we're going to use the quadratic formula. So the opposite of b, so -5 plus or minus the square root of b squared minus 4 times a times c all over 2a. And then we work it out. Again, I showed you multiple ways last week. I'm going to do it kind of step by step. We work out the discriminant, everything underneath the square root. And we get 49 divided by 2 times 1 is 2. And then you can use your calculator. Remember, there is the calculator on the computer if you don't have one in a previous announcement. And so the square root of 49 is 7. So -5 plus or minus 7 divided by 2. So we'll do -5 plus 7 divided by 2. We'll do -5 minus 7 divided by 2. And don't forget to use your parentheses. Okay, and so then you'll type these in. And -5 plus 7 divided by 2, we get 1. And then -5 minus 7, all that divided by 2. And we get -6. So a couple things that you're going to look for as you go through problems. These are rational numbers. If you get rational numbers, that means you can do all of the other forms. I'll talk about when you don't get rational numbers, so make sure you really watch for that. As long as your answers are rational, you'll be able to find your answers pretty much in all the different forms. The table could be a little bit iffy. The graph may be a little bit iffy, but that means you can definitely factor it. After you know what your 2 answers are, though, it makes no difference which of these you go to. You can totally choose which one you want to do next. I'll go ahead and fill in the table. So with your table, if you can remember, the whole point of solving is to find x-intercepts. So if I'm trying to find x-intercepts, that means I want to find where my x value, where my y value is going to be 0. So you can put it in x squared plus 5x minus 6. Now, sometimes you can see it in the table and sometimes you can't. So when you want the y value to be 0 right here. And then it happens right here. And look, that's the same answer we got. We have a 1 and we have -6. So all I'm going to do is I'm going to do the 2, like I'm going to do negative. I'm just going to fill in the table. I'm going to put the -6 kind of in the middle. So I'll take the 1 above it, the 1 below it, and then I'll come down here to our other answer of 1, 0, do the same thing. The 1 above it, the 1 below it, and put that one in the middle. So you have a table that you can get to. You'd have to use the online graphing calculator that I put in another announcement to be able to find this table to fill in the chart. So -7 and 8 was there, -6 and 0, -5 and -6, and then jump down to where you see the next set. So 0 and -6, 1 and 0, and then 2 and 8. And again, your answers are where the y values are 0. Be careful, don't get tricked. This is not an x-intercept, this is the y-intercept. And while it's a good answer, helps us find some things, it's not the actual answer. Okay? So another way to do it is by graphing. And you can just take these points and graph them. Usually when I have you graph the quadratics, I ask you to make sure you always graph the vertex. We can find the vertex easily especially if we have the graphing calculator. Remember, we add the x's and then divide by 2. So we can do -6 plus 1, divide by 2, because remember it's in the middle. Okay, so then again, you can use your calculator, you can just do it in your head, whatever works for you. And so we do get -2.5. Well, and if we look at our table, well, there's not a -2.5 in there. If you remember, we can do second window, put in -2.5, second graph, and then that's your other number. So your vertex is -2.5 and -12.25. Or you can take the -2.5 and substitute it in for all your x's. We're just going to graph this parabola. So -7, I know the numbers are a little bit hard to read. They count by 2s. I mean, or you can count all the lines, but that's -7 and then a +8. Let me see. Okay, the zeros, the x-intercepts are what really matter. If you mess up one of the dots up a little bit higher, I'm okay with that. But the -6, 0 is super important. And then we have -5, -6, 2, 4, 6. Okay, I have 0, -6. I'm going to put my vertex in a second. I have 1, 0, and I have 2, 8. 2 and 8, and the -2.5 and -12.5. So down there. Again, the important part of this graph is where it crosses the x-axis. If the rest of the graph looks a little bit iffy, I'm okay with that. All right, and then the last part would be factored form. Again, every time I do this, I should be seeing -6, 0, and 1, 0. -6, 0, 1, 0. I didn't write them as ordered pairs, but I've told you that's okay as well. -6, 0, 1, 0. So that means this will factor, and it needs to give me 2 nice answers when I do that. So I'm looking for numbers that will multiply to give me -6, but add to give me 5. And I have to use 1 and 6. And I want to get a +5, so I know my 1s are negatives. So x squared minus 1x plus 6x minus 6 equals 0. All the factor by grouping. So again, everything we've basically done keeps coming back. And this, like I told you before, the factoring won't go away. So I know on some of those weeks I gave you a little bit harder time on your classwork of not being complete, but partly because it's going to keep coming back. And I want to make sure you know it. Remember, when it equals 0 and we're solving, you got to finish it off. So the x plus 6 equals 0, x minus 1 equals 0. Subtract 6, so I get x equals -6. Add 1, and I get x equals 1. And again, every single time I worked it out, no matter which form I was doing, I have to get the -6 and the 1, which is why I suggested starting with the quadratic formula and then going to whatever other form you want to go to, because, and I'll show you on the next one, something different happens when I don't get nice answers, okay? So if I get nice decimals, that's good too. Any of the rational numbers are good, and I'm going to show you what happens when your answer is not rational. Okay, same exact thing. I still strongly suggest that you start with quadratic formula. I would not start with any other form. What's nice about this one is that it's already set equal to 0. Sorry, it's already set equal to 0. So I'm going to move it back here, and then you should be able to see the rest of the work. So A is 1, B is 7, C is 4. And so we get the opposite of B plus or minus the square root, B squared minus 4 times A times C, and all over 2 times 1. Again, I would work out your discriminant again, so -7 plus or minus the square root, and the discriminant's 33, and divide by, and 2 times 1 is 2. And then I do -7 plus or minus. And when you do, I'm going to show you, the square root of 33, sorry, there's a little bit of glare. You know, I get this decimal, and it's not necessarily a nice decimal, it's fine, but it's not going to be like 1.5 or 2.25 or 2.5. So this is one of our irrational numbers. Remember, our irrational, we can't change into fractions. And I asked you in the last part that when you get an irrational number, that we're just going to round 2 decimal places. So we're going to do -7 plus 5.74. and -7 minus 5.74. Okay, and so we get x equals, and we get -0.63. And on this side, we get x equals -6.37. So again, because I got irrational numbers here, that's going to change some things. So I hope you watch what happens if your answers are irrational, meaning you can't change them to fractions. So I know we look at this and you're like, well, we can't change those to fractions, but we've talked about it before. We can change that to a fraction by just putting a 1 under it. So if they're decimals and you can't change it to a fraction, that's an irrational number. So let's look at the factoring next. Let's just mix up the order. So just to show you, it doesn't matter which order you decide to go in. So we want to have numbers that will multiply to give me 4, but add to give me 7. Well, 4 is only 2 and 2 and 1 and 4, and that's not going to help to give me 7. Remember, if you can't find numbers to go in the blanks, that means this is going to be prime. Can't factor it. Now, that will always happen when you're dealing with your irrational numbers, okay? So if we have to round here, we're going to have prime. It's not going to factor, just so you know, okay? Now, that also is going to change a little bit with how I do my table. We'll have to do we'll do some more estimation with our graph as well, because again, the important part that we're learning right now, or making sure we're going back over, is solving our quadratics. I am not concerned with the graph and our vertex technically right now. So when you go to graph this one, let me put it in. We're going to do x squared plus 7x plus 4. And go to look at our table, and when I look, I'm like, okay, well, all these numbers are like really big, and that's okay. So when you actually, let's see, when you go to do this, then what we can actually do is we're going to move in our table a little bit, and I'm going to go, okay, well, I'm looking for where y is 0. Well, I don't see where y is 0. Y is never 0. Well, what you do start to notice is that your numbers here go from positive, 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 and then to negative. And then if I go down here, I'm negative, negative. Oh, there's positive. You find your zeros, unless you really see it in the calculator where you see the 0 in the y1, when the numbers switch from positive to negative or from negative to positive. In between those numbers is where your x-intercepts actually are. So unless you see the 0 physically in the y value. What you're looking for is your numbers to switch from positive to negative. If your numbers switch from positive to negative, in between that spot is going to be where your x-intercepts come from. So if I go back up here, I switch from positive to negative here. Okay, so I'm going to put negative 8, 12. I'm going to zoom this back out in a second too. Negative 8, 12. And then, again, if I keep using it, the next one's a negative 7, 4, and then the negative 6, negative 2. So negative 7, 4, and negative 6, negative 2. Between, let's see. Between where it goes from the positive to the negative, in between here, that's where your x-intercept is. And if I look, between negative 6 and negative 7 would be this negative 6.37. So when it switches from positive to negative, the second time it happens, negative 1, negative 2, 0, 4, 112. It switches from positive to negative here. That's where your other x-intercept would be, in between the negative 1 and 0 and negative 6.3. Negative 0.63, sorry, I said that wrong. Negative 0.63 is in between negative 1 and 0. And then you just graph it. Again, I'm more concerned that when you go to graph it in, that it's both on the negative side. Both of your x's, your x-intercepts should be on the negative side of the graph. You can even look at the graph on the calculator. Mine has an extra red line that's going to come up. But again, you want to make it look as accurate to this as you can. So if you're graphing and you have like 1 0 here and 1 0's over here, well, that's not what the graph looks like. So just make sure you keep them both on that negative side. We'll plot some of these points. So we have negative 8 and a positive 12. And negative 7. Let's see, that's 8. So 7 and positive 4, positive 4. And then negative 6 and a negative 2. And negative 1 and a negative 2. 0, 4, and 1, and 12. And again, we can't really see the x-intercept because my axis symmetry is not going to be as nice. I mean, if you want to use it's going to be an estimate. But you can take these two values and we can add them. And then divide by 2. So it's at about negative 3.5, negative 3.52. And again, you can use your table. Like I can do second window, put in negative 3.52, do second graph, and then you can see that it's about at negative 8.25 for my vertex. So close to that. Let's see. So negative 3.5, so there's negative 3 here, and then like 8 point, let's see, so somewhere kind of in here. Oops, too big. Okay, and then you just graph it in. So both my x-intercepts stay on the negative side of the graph, and they're close to the negative 6.3 and negative 6.37. You should be plotting actual points. I know that some of you, sometimes when we look at problems together in class, I have to remind you that you should be plotting points. So just use the points in the table. They're right here, but make sure you plot actual points. I should see the dots on your graph. And again, if you get irrational numbers, so not nice decimals, you won't be able to factor it. And everything else will kind of be estimated. You can't see it perfectly. As if you get the rational numbers, hold on, let me move my calculator. As if you get the rational numbers, you can do all of the parts. Okay, so this is just putting everything together. We've done quadratic formula. We've done factoring. You know how to use a table. We know how to plot points. That's all we're doing with this set. Again, part 2 will be a review of material from work that we've done in the past, and I just think we needed a little bit more practice on it.